Welcome in first practical of MAXIMA Software. In this session we will learn what is MAXIMA. Second, what is the history of this MAXIMA Software, the interface we will use here, and some beginning commands we will use in MAXIMA Software, how to save a file in MAXIMA and how to apply the simple operations in MAXIMA Software. So the first practical is to simplify expressions, factor expressions, expand expansions, and to do trigonometric simplification and complex simplification by making use of MAXIMA. It's our first practical. I have divided this practical into 5 sub-practicals. So in the introductory part, let us take what is MAXIMA. MAXIMA is a computer algebraic system. So here we will learn what is a computer algebraic system. So computer algebraic system is mathematical software programs which facilitate us symbolic mathematics. Here we not only manipulate mathematical expressions in the symbolic form, but also support numerical and graphical computations. We will learn all these in our practicals. So there are various computer algebraic systems, and this is your Viva questions. Give the name of different computer algebraic systems. The first one is MAXIMA, which is in our syllabus, then Maple, MATLAB, Mathematica, and Python. So these are some computer algebraic systems. Now the question is, what is the history of MAXIMA, how it came in the existence. So the MAXIMA word is obtained from max, symbolic manipulations. From Mac, these 3 words are obtained from MAC, symbolic SY, and manipulations first 2 alphabets, that is MA, and it becomes MAXIMA, this one. Okay, it was developed at MIT in the year 1968 through 1982 as a part of project MAC. That's why its name is MAXIMA. Initially it was known by this MAC SYMA, MAXIMA. Now we are taking this as MAXIMA. I will tell its journey. After it was introduced in 1968 and struggling in 1982, MIT, actually MIT is a private land grant research university in Cambridge. So this MIT turned over a copy of MAXIMA source code to the Department of Energy in 1982, and this version is now known as DOE, Department of Energy of MAXIMA. The professor, respected William F. Shelter in this university, got a copy of DOI MAXIMA for maintaining these code words, and in 1998, Shelter obtained permission from this Department of Energy to release this source code under the GNU public license. GNU public license, and in 2000 he initiated the MAXIMA project at SourceForge to obtain and develop DOE, Department of Energy MAXIMA, now called MAXIMA Software. Okay, this code was given public license in 2001. Now we all different versions came out during the last period, and at present we will learn this MAXIMA, MAXIMA. This is our open source software. Free of cost, you can download this from the site, and it help us to help us to symbolic computations as well as graphical computations. We can say Maxima is full-featured computer algebraic systems, as I told above, and the logo for this one is this logo which is on your screen. Now for any software we need a interface, and here the interface used simplify software several graphical user interface for simplifying its uses. Two of them are X Maxima and WX Maxima, and most user-friendly interface is WX Maxima. We will work on this interface. WX is small alphabet and Maxima. Here's lowercase and uppercase sensitive in Maxima software, and there is a Viva question which interface you are using for your Maxima. So you will reply there WX Maxima, and it is a graphical user interface which provides the full functionality and flexibility of Maxima. You will see it when you run your programs, and it offers user a graphical display and many features that makes working with Maxima easier. Now for demonstrations, I use first some basic operators which you have learned in your classes, that addition, subtraction, multiplication, division, exponent, all these. So before starting this, I will tell you how to start your Maxima programs. I have built a shortcut for this on my desktop. For practical, this is my shortcut. I will double click on this software, on this icon, and this window is open here. Here is a Word file as you have seen, then edit. You can open a new, this is new interface. There are 5 windows. First is Greek letters, mathematical symbols. There is insert, it is history and table of content. When you put something here on this blinking cursor, then you will see there is something in history box and something in your table of contents will appear. First of all, I want to save this, so go to file, there is new, open, recent, close, save and save as. So you should go to the save as and save this by the name, as I already saved this Maxima program. So it's practical first, so I will write here practical first. You can take underscore here, underscore first, and this is introductory, very simple calculation is here. So operation I am using here, so you can write here 1.1. so 1 point is not there, 1 underscore 1 I am writing here. Remember there is extension of dot wxmx because you are using interface WX Maxima, so this should be there. So I wrote here save. Here the name is practical11 appear on this space. Now you can write here something. I already wrote this one. I already written all these here, so I'm opening that window here first, and this is this one. So my practical, as I told, to simplify expressions, factors and all this. I told you what is CS, so I'm skipping all these terms here. So next topic is simplify expressions. For this I need addition, that is denoted by plus sign, subtraction minus, multiplication is given by star, and this is appear on the key 8 key in your keyboard, and then division, and this symbol is enunciations, that is also known as the power here. So how to add the two numbers in MAXIMA software? You will write 2 plus 2. I am eliminating this here. I am writing 2, then plus and 2. Now for enter this in the memory, you will write here semicolon from the keyboard. This is colon and semicolon. Okay. Then you will write here termination. So you will write enter control and enter. So your output 2 plus 2 is 4 appear on your screen. Here is this label, brackets start and close. There is %i1. This shows that you have entered 2 plus 2 in the input cell 1, and your output appears is 4, and that is output cell again 1. Now you can take any difference, you can multiply, you can divide. Suppose I want to difference of two numbers. Suppose you want to find 3 minus of 1. Again you will write a semicolon, which is already here, and you will write shift enter. Again you will obtain 2, and this is on your input at cell 2, and you obtained output on cell 4. Next I wrote here 3 into 4. Here is not a dot. If I put here dot, simple dot here, then there will be error. This dot is working here. So not working here, sorry, because I wrote here dot. So you should write star. Now I am putting star here from the key 8th key in your keyboard. If I put it here, then it will gives you 3 into 4, 12. One thing you should note here, that is I wrote 3 into 4, 3 dot, simple dot from the keyboard, and that input was given in the cell number 3, which is not appearing here because I already write on the same input space. But in the computer memory, 3 into 4 in 3.4 is stored at the cell number 4, and the output, which is again 3.4, that is on the cell number 3rd. I modified that statement. I obtained the input at the 4th row. Now I am dividing 9 divided by 3. The answer will be 3 into 4. Let us take the what happened when I did not put the semicolon here. I am not putting semicolon and I am entering here. I am pressing enter from the keyboard as I told in the class. So this not terminate. The semicolon means is you are saying to computer to terminate your command. I already wrote these lines here. So first let us check this one. I am putting the semicolon here, and now I am pressing control and then shift. So 9 divided by 3 is 3. Okay. Here not decimal system is not working. Float. I will discuss this in the coming lectures. Now I am taking the power. Exponential symbol is this. This symbol is your power. I am writing here 2 power 3. The answer will be 2 power 3 is 8. So I am again putting here semicolon and shift, control and enter. The answer is 8. Okay. I am taking a 3.4 and its power is 2. Decimal system here. I wrote here 3. This is star and 4. You can write the bracket here, but it will work without bracket also. So you can practice it. So this shift enter. This answer is 11.56. Suppose I want to write many terms here and I don't want the output every time. So how to obtain this? That your command is terminate, but your output are not appear on your screen. You don't want this output 07. For example, let us take 3 power 2. For this I need this symbol. This is your dollar symbol. Okay, so write it here 3 power 2, and I'm writing dollar from the keyword 4 in the second row of the keyboard. Enter. This output is not appearing on your screen, but I want to check whether the answer is 9 or not. So for this I need this symbol here, percent. If I put the percent in the next cell, this is my cell, this is the symbol of your cell. If I want to check what is the output at percent output 8, so I will put this percent sign and termination of this command, that is semicolon, and control enter. I am obtaining the 9 here. This is the way you can check. Suppose I want to check the output at 5th per number. For this you will write here percent output 5. On your 5th row, 5th cell, your output is 3. So you can call at any time during your compilation. So your output is on your screen. So the input are shown by the prompt %i, and here is your number. So these are your input 7, this is input 8, this is input 9. Similarly, the output are shown by the prompt %0. Okay? Your I label denote your commands, and O label display the machine's response. Machine response means you have entered your input in the computer and you are obtaining the result in the form of this output line. Okay, and I want to suppose close this program. So for this session close, I need this quit command. I will write in the end QUIT, quit, bracket start, close, and semicolon, and then enter. Here the sample sessions semicolon to finish the command is followed by the return साइंस डॉलर. देखिए आप यहाँ पर semicolon, I already told this in input semicolon is to terminate this command, and I already told this $sign here. So here you will write, this is, you will not write all these in your practical, you will write in the practical is these commands, and this command is for your Viva questions. You should know what is the use of this semicolon at the end of this input command and what is the role of this dollar, and this dollar is suppress your display of maxima computations. Means here is 3 power $2. It's not showing you that this is answer is 9. So it is pressing the display. Now here I'm just taking the additions. If I want to assign a value in a variable, how to do in the MAXIMA software? You can easily do this in your MAXIMA. So for this you will write the variable on the left hand side, and here you will not put the sign equal to here. Here you will put the colon here and the value here. That means your symbol is variable, variable, and name of the variable in which you want to assign your value, and there you will put the colon here, and here is the value you want to assign this variable. So here you will write the symbol for this is variable name. this is your syntax to assign a value in a variable. So you will write, this is syntax. The syntax is variable name, and then you write a colon here. In our mathematical language we assign equal sign, here is colon sign. Okay, here is an example. I am assigning value 3 to a. So a is equal to 3 is done by this statement. So I am writing here colon and this one. Suppose I want to check what value I assigned in the a variable. So I can check this by just writing the a value in the cell, and then this semicolon here, and now I am entering. So control enter. So it shows that a value is 3 here. I am also assigning one of the variable, that is b, and I assigned here b colon 4. It means I am saying b equal to 4 here. So in computer memory at input number 13, I assigned b equal to 4. Now the variable b has the value 4. Now you can add these, you can multiply these two values and assign the new value into the another variable. Now to add these variables, I am taking the sum of these two variables a and b. So I am writing here sum of ab, just for checking whether here is the answer of sum of two number a and b. Now tell me what is the sum of a plus b. In a I assigned 3 and in b I assigned value 4. So when I put sum of AB, here I am adding A and B, and this value is assigned to sum of AB variable. So sum of AB will contain the value 7. Let us check what is the answer. So I have put here colon and shift enter, that is 7. On the same way I can multiply these. So I have done this by, I wrote here product. If you want to find product, if otherwise you can write any variable here. Suppose you are saying pro means product of AB, and I wrote here colon will do the work of assignment. It will assign the value of product of A and B. You can take any another operation also. I am taking A star this b, as a is 3, b is 4, so it will be 12. Let us check. If I write here just enter, it will not work because I did not mention the terminations. So I write here backspace, I am putting semicolon first, then control and enter. So it gives me the answer 12. I can write here the power of a. I am taking a power b colon, a is 3, b is 4. 3 power 4. 3 power 4 semicolon and control enter. The answer is 81. Suppose I want to check what is written in the input I13. You can just write here %. If you forget during your work and you want to check what you wrote in the input I, suppose 13. So shift enter semicolon control enter. In 13 I assign the input b equal to 4. So you can check any input in your different cells in MAXIMA software. Now how to take the square root of a number and assigned values. Suppose square root. The syntax for this one is, first of all you will write the syntax for square root. The syntax for square root is inbuilt function in your MAXIMA software, that is square root. So you will write control V square root SQRT and the number here, the number whose square root you want to calculate. So in this next line I have wrote here, you can directly take square root of 64 and the answer is 8. Suppose you want to assign this value into a variable. So how will you do this? You will take square root of this number, write here the variable name. The variable name is my x. This is my line. X, I am assigning the value, so I will put here colon or semicolon. Here I will put colon and the square root of 64, and then I wrote here semicolon, control enter. The answer is 8. Now you can take the power of x, that will be 64. So I wrote here x the power 2, control enter, 64. You can do the power work as x star x also, your answer will be the same. Semicolon enter, answer is 64. Suppose I have wrote here a is equal to 3 and I want to assign the new value, or I want to make a as a constant. So in a I have checked this is 3, but I want to eliminate this value from the a. So for this there is a command kill and it will eliminate the value from this. I am writing kill. The syntax for this is kill bracket start, and you will write the variable which you want to empty here. So I write here kill a and this one. It means done. Done means now the value a is removed from the memory of a variable. Suppose I want to check it. देखिए a semicolon. Previously in the 22th cell I obtained 3, but here I am not obtaining any a. Suppose I have assigned the value a is equal to 4. So c is 4. Again I will assign new value to a variable because I want to take the sum of all a, b, c. So a colon. Suppose again I want to assign the value 1. Now what is in a? That is 1. What is in b? In b I assigned, let us check what I have assigned in the b. Suppose I am writing b semicolon and this one. I assigned b is 4 and in c also 4. So what is the sum of all these three numbers? That is 1 4 plus 4 plus 4, that is 9. Let us check. So I wrote the new variable sum3 colon a plus b plus c. Shift enter. The answer is 9. Now let us take the history, what is written in the history box here, and table of content. Now in your history, that is this is your history box. What you have done in your main box, that is written in this window, and table of content, that's in the various cells I use in sections. I defined here CS, simplify expressions and other terms. I wrote here to find the square root of all these. Okay? These are the mathematical symbols which we will use in further lectures. So in this way, now the last line is how to quit from this session. I already told that there is a command quit. So I am writing here QUIT quit, bracket start, close, semicolon. You will write here control and you will write enter. You will obtain this one. When you press this one, Maxima exited, trying to restart Maxima. When you do this, every history clear here. You will not obtain anything in the history box here. In this case, if you want to take the output again, so you have to again compile it again. Now suppose you want to eliminate these output from this, so I will tell how to remove these lines directly from the compiled programs. So this is your introductory part of FOSS practicals. If any problem, ask in the class. Okay, thank you.